So, good morning, everyone. Well, I would like to thank all the French and Indian delegates coming here and making this conference a success. Oh, so am I audible here? Okay, good. So, well, this is the picture of our other campus. Some of you have not visited it. So again, a very green campus there, about 10 kilometers away from here. So our institute works in science communication and policy research. So I'm working basically in policy research group, and I'm basically working in analyzing scientific networks. So there I encounter, something in network analysis, this citation networks at some point, and found some new very interesting methods which have been introduced like in last 5-6 years. So I will review some of them. I have some certain ideas. We have not published this paper, this work yet, but I would like to discuss these things also and describe how do we manage to do that because of this open data that is available on OpenLX. So let me start here. So of course, at some point you have to understand what is the impact the science is creating. And if you see, the number of papers is doubling after some finite interval. So as Derek D'Souza says, scientific growth is exponential and can be measured from the number of publications. So recently Bondman has estimated something like 17.3 years. Every 17.3 years, you are having double of the number of papers. So it means you are putting a lot of effort, and that is growing exponentially. But the question is whether we are really advancing in science. For advancement, to understand the impact, the most popular measure is basically citations that you consider, that how much citations a paper is receiving. It's an indication that how much advancement is coming there and how people have looked the scientific development from the research output. So, but we know that citations have problems. They are not unbiased, and they actually collect only few. These are proxies to capture the impact. These are not exact measures. Of course, exact measures you can't design, but they actually contain only certain kind of information. But still, they don't have a good substitute right now. So H index, much criticized index, it is not fair, but at least it combines the number of articles and number of citations. It gives you some point to compare the things, researchers or aggregators of knowledge, research papers. So it gives you at least a platform. But of course, it is criticized. EGA introduced another index, G index, which compares the researchers, but also they credit the researchers who have some good papers, well-cited papers, a famous paper in their portfolio. But citations are biased. Von Rand introduced crown indicators from CWTS, and he mentioned that, okay, one has to categorize the research papers in different areas based on their subject criteria, their publication journal, year, and then you do the normalization along with that line. Some technicalities when he introduced this crown indicator was pointed out by Jonas Lundberg. Afterwards, Wortman corrected this data and he introduced MNCS indicator, mean normalized citation index. And they have shown some empirical examples as well there later on. Bondman actually have gone through these indicators very carefully, and he just questioned whether should the citation be field normalized to in evaluative bibliometrics, and he came up finally in the result. He wrote another paper where he gone through all those articles, what kind of citations, what kind of factors which can impact citations, and then he came to the conclusion that okay, one has to normalize it to reduce the biases. Of course, you can't remove the biases, but at least it can be reduced. Later on, people have started thinking on that it's not the citations which is the only thing we can look at, which one should look at also into the citation networks. The first study that I can see here is from Russo and Hu, and they studies not citations but citations of citations. And they presented an example of U22, the Nobel laureate of 2016 in medicines. And they said, okay, this kind of, you go further into the citation, not the first order things, not the citation counts, raw citation counts or normalized citations, go for the second order things, citation of citation, then you get a better picture. At the similar time, Ioannidis and etc. was advocating for using composite indicators, including the authorship, positions of the authors, if you are talking about authors, then fractional counting and fractional H index, etc., etc. So they have considered 6 indicators, and they came up with some. They have developed the data and came up with some results. But at the same time, something was happening. Recently, you see an article that appeared here in American Economic Review. It was actually a working paper series, appeared in 2017 and then published in 2020, where they say our ideas are getting harder to find. And they said that actually the efforts we are putting in, it's not resulting into advancement of science and technology. We are not actually getting very disruptive results now. Later on, you see Park, who has written Nature last year, Park, Leh and Funk. So they actually have done this scientific bibliometric analysis, and they have considered the citation network there. And from there they find out that actually research is a decline. This creates a headline for many newspapers, you see. And OECD documents where they have mentioned this paper categorically, that actually something is happening with current day science. This is the result what they showed. On average, the whole, different domains of sciences are actually on decline with time. And same things are happening with patents. The index, what they use is basically the index which have been developed here in Nature in 2009 by Wu, Wong and Wans. They used it here. The thing is, whatever they do, they consider large data because they are dealing with citation network. So they have to deal with large amount of data, 42 million papers, 45 million papers, 26 million papers. The latest one is from Barabasi and K, where they introduced an alternative indicator for CWTS group. What CWTS group is doing for categorizing it, they introduced a network measure as an alternative to that. So, well, we have access to open WS data, but the problem is the size. For that, you have to buy API, which is costly. So I turn my attention to OpenLX, which is free, available. Anybody can reproduce the results because it is openly available. They give you API, you download the data, you get many of the languages included in this data. So I said, okay, let's see what is happening there. On their website, they have almost the largest amount of data and many citations equivalent to Web of Science. Authors, they actually disambiguate the authors in WOS. You just get ORCID IDs, etc. But here they actually done this exercise, and report says this exercise is actually done at a very good level. So if scientific network, if you're going for co-authorship and author-centric networks you are analyzing, then this kind of data may be used. What are the index? The first one is the disruptive index, which here we don't talk only about the citation counts, which say how they are citing the papers. So X, let's say, is the number of articles which is citing this focal paper F, for which I want to calculate this DI index. So F is the focal paper. So what we do, you calculate all the papers which is citing it, then categorize it. Papers which cites F and its references, that is X, and papers which cites F, focal paper, but not with its references, and papers which doesn't include that references. So this gives a kind of transformation things that it is doing this focal paper is doing in citation flow. That how far people have recognized this paper from the references, how different it is from their references. And then Z also, which is always indivisible, and there they found that they check that how many citations this references have received with respect to if you exclude all the citations of F. So then they define this DI. So DI, when it is greater than 0, then they say they identify paper as disruptive. It's less than 0, they say it's a consolidating or developmental. So and that is what they have done for this 45 million paper data that they have calculated, and then they plot the average data, average values of DI for each year. And this is calculated for a time window. A time window size is something like 10. For 5 you can set. So they have calculated this DI on average data. They have found this. At the same time, Barabasi and K introduced a new measure, which is an alternative to CWTS methods of categorizing the science in different journals and publications with respect to the journals, subject categories, years, etc. So it is basically a cumulative index. Some of the citation, normalized citation, for normalization, they again take this focal authors. They look at the local network. They consider focal paper and looked into the citing papers which co-cites as a paper. For instance, this is a citing paper at time T, and their references. These are co-cited papers with F. So how many citations these are getting? And on average, how many citations these are getting? So they use these average numbers and normalize it. The citation the F is receiving in time T, and they did it for, let's say, time horizon T. I mean for every year, sum it, and they say this is the network where this is a citation, a normalized citation, which is unbiased. Well, not totally. We have also done some analysis. We see, okay, at least these biases are reduced when you talk about, when you think about the, in terms of field and temporal impacts. So now, this is the methodology that we have thought about. Okay, let's say, I mean, for OpenLX we calculate, I mean, we have downloaded data for physical sciences. So let's say if you calculate the local citation network, from there you calculate NB&C scores. So you have normalized citations, and then you also calculate DI index. Then the top ranked papers based on this score, you identify as a breakthrough, and then for this breakthrough you can categorize this breakthrough in 2 different parts, like disruptive articles and consolidating articles. So you now have 4 phases. When DI is less than 0, that is disruptive articles, and then you can think of the phase when NB&C, the breakthroughs, are on decline. The second thing, when DI is less than 0, but breakthroughs are on incline, when science in the phase when people are now consolidating the existing ideas. But breakthroughs are coming, at least good papers are coming, quality papers are coming. The third one is when disruptive is actually driving, disruptive research is driving the whole system. And the last one, when disruptive result is there, disruptive research is driving the system, but NB&C, the breakthroughs are not actually going up. And the fourth one, when breakthroughs are on, disruptive is driving the whole system, and you are getting also the breakthrough research. So we collected the data of something like 60 million papers, comprised of 10 fields, which covers 10 fields in physical sciences, 88 subfields and 1300 topics, and evaluated these scores from 1900 to 2013. Actually, we have considered for analysis 1950s onward, because earlier we didn't have much data, and then we identified the breakthroughs, and then we start looking at the trend, that what exactly is happening. So we use this time series analysis, and we use the non-parametric time series test like Mann-Kendall test, and this is how this time series will look like. In one more slide, I will finish it. So this is, you see, actually the breakthrough research are having some pattern, but disruption is actually on decline. And you see most of the time, except in this case, biomedical engineering. It has some different pattern that has emerged here. Then here also in building and construction, you see things like breakthroughs are going up, but disruptive articles, number of disruptive articles are on average are on decline. After 2000, start seeing these patterns. What the test says, I mean, in most of the cases, the research scientific phase is like in developmental phase. Of course, disruption is on decline. You don't see this kind of trend. But on the other hand, in some cases, we see that actually the developmental and disruptive both are on incline. So, well, this is one perspective that I am showing you here. We are actually still doing the analysis, working out the more carefully, the more results about that, try to learn how these scientific phases are evolving. But of course, these two indicators actually are giving very new perspective, which in my understanding has never been seen earlier. So let's see what turns up. I mean, we are still working on that. So maybe not many more things to conclude right now. So, but of course, citation network is the thing that we have to look at. If citation counts or not, the only thing that one should go for, move forward. So thank you.
Long live India and France friendship.